It's great to see so many people here at the very end of the conference. That's really a great thing. And what a great conference. I would like to actually thank the people who put this on, Jim and Monica, very much. I think they need a round of applause. So, Phoenix is not your application. That's sort of a bold title. It's really more like this. Phoenix is one of your applications. And when we talk about building web applications, the things we say actually say a lot about the way we think about them. So we say things like, I'm building a Phoenix app, or a Rails app, or an Ember app, or a React app. But is that really true? I think no. But the way we approach it right now, it sort of is. But it doesn't need to be that way. So ideally, we would say things like, I'm building a logistics app, or an analytics app, or a physics engine, or a fortune cookie app with a web interface. So the application has its own domain, and Phoenix is the interface. And Phoenix has its own domain as well. So let's do a thought experiment. And this is in Rails. I want to make it clear, I love Rails. I've worked in it for a long time. Not as much as I love Phoenix. Considering the response that Volker got yesterday to his question of, who's worked on a big Rails monolith, I figured this was going to be good. So let's say, here's the experiment. We have a big Rails app, a whole bunch of models, whole bunch of controllers. It's been migrated a bunch of times. The tests are pretty good. And now what we need to do is we need to put a new framework on it, right? So the experiment is, how does that make you feel? Yeah. But why? Why does that seem so daunting? I think there's a couple reasons. One is that the application logic is entangled with the interface, right? So think about the way that we build applications with a framework. We add pieces of the framework over and over and over again to build our application. Like we'll add a route and a controller and a view and templates. And really, like our application is a different thing. So taking pieces of the interface to build the application seems backwards. But we're so used to it, we don't really even see it sometimes. So that's one. The other thing is that because we build applications with pieces of the framework at a time, our application logic is dispersed across those pieces, across models and controllers and views, and maybe even templates, even though we know we're not supposed to put logic in the templates. So when we do things this way, maintainability becomes an issue. It's much more difficult to pull things apart. It's much more difficult to see where problems are coming from. Are they problems in our logic? Are they problems in the way we've wired the framework pieces together? Difficult to figure. Also, portability becomes an issue for our thought experiment. The most likely scenario is that we're going to have to rewrite that application. And because logic is dispersed, it's going to be very difficult to make sure we get all the pieces. And you know that somebody in a department somewhere or somebody who's a user of your application somewhere is going to find it and complain. And tests are great, but they can't guarantee that you're going to catch absolutely everything. So the solution, I think, is to build our application separately first and then layer the interface on later. So before we get into that solution, let's think a little bit about how this happens. So how does this happen? So I have a way of thinking about this. There may be other ways, but this way makes sense to me. So to me, it begins with the HTTP request response cycle. And how does that work? So HTTP is stateless, but applications are not. Applications need state to do anything that's interesting. So we store state in a database. And then whenever we have a request, we go off to the database and we get new state, and we formulate a response, and we send it off, and then we drop that state again. So if there are any changes to the state in responding to that request, we need to write those changes back to the database. And so we lean on the framework for data access, and that totally makes sense because we get a standard interface, everything works the same way all across the application. That's great. But what it means is that we start to model our domain entities for databases, right? So we start really caring about foreign keys and join tables and many-to-many relationships. And those things aren't really part of our domain, right? So this is also going to be an active record example, and mainly because it shows so clearly what I want to get across. So let's consider the difference between these two things. So one is comment class, simple. The other one inherits from active record base. So what do we get with the first one? It does comment things. But the one that inherits from active record base does all kinds of stuff. It knows how to talk to databases, it knows how to make queries, it knows how to validate data, all this stuff in this one class, right? So a comment is part of our domain, but the comment model is part of active records domain. So instantly we're entangled, right? So of course, Ecto has a better story than that. And as Michelle told us earlier today, we don't have any more models. We only have schemas. There's a good separation of concerns, but we're still thinking in database terms, right? And for some instances, we need a database, and that's great. Use Ecto. But I think in building applications, we have the leeway in Elixir to not have storing state in a database be the default. We have other options, all right? So models are not part of our domain, and a router probably isn't either unless you're doing a logistics app or a controller or a view. So we need to decouple our domain from the framework's domain. And it's great to do it in code, but if we do it in our heads and we think differently about how we're building applications, that's where the real progress comes. And OTP has an answer for this, called OTP Applications. So an OTP application is a behavior. And what really is a behavior? So it's kind of hard to explain all the nuances and all the bits of what a behavior actually is. Concurrency, distribution, fault tolerance, really hard problems. The Erlang team spent a lot of time getting those problems right. And what they did is distill their best practices into these behaviors. So that's one part of it. They're also kind of a design pattern, but maybe not, more of a concrete design pattern. And then there are two much more concrete bits. One is that there is always a module inside of OTP which holds the code that is common for all instances of that behavior. So like applications have to do certain things, and every application has to do those certain things. So the module in OTP will extract all that code and hang on to it. Then there is also a list of callbacks, which on the one hand we must implement, and on the other hand we get to implement. And as we get to implement them, we can customize our own instance of the application. So what is an application really? That was a behavior. So it is a module or a group of modules that implement a piece of functionality. And that sounds a lot like a component, maybe. They can be started and stopped independently, and that implies that they're supervised. And this last bit is the interesting bit. So since they can be reused in other applications, we can compose bigger and more intricate and complex applications out of small ones. And that's what we're going to do. So we already use applications all the time. So let's say we had a freshly generated Phoenix application called Hello Phoenix. If we look in the mix.exs file, we'll see that we have this list of applications here in an application function. Now that list is used to build, I believe it's called the application resource file, the .app file, and that is something that the Erlang virtual machine will use to use the application properly. So we can take a look at the applications we have in a running server, and again we'll say we have that Hello Phoenix application. We just start it up and run observer.start. Then we'll get this GUI app, which many of you may have seen before. But if we click on the middle tab there, the Applications tab, the list on the left, those are all the applications that compose together to make your larger application. And inside that Hello Phoenix application, we need a module to define what our own app is, right? And that's in lib/hellophoenix.ex. You have one in any Phoenix application that you have. So this line right here, that's where we inject all that common code that's in the OTP application. And this guy, the start2 function, this is how we customize our own application. And we customize it by determining the child processes that we're going to start up when our application starts. We get to determine whether they're supervisors, workers, what modules they're going to be, and then we determine what strategy we're going to use and pick our top-level supervisor, and then we make sure that when our app starts, those will start as well. And so that's a cool story, but how does this actually help us in doing anything? So we can approach building an application in a different way. So we can create a pure Elixir application first. Then we can generate a new Phoenix application that is the interface, bring the Elixir application into the Phoenix application as a dependency, and then have the Phoenix parts talk directly to our Elixir application. So in other words, we're going to go from this, some people might call that a monolith, a big box that takes in requests and sends out responses. We go from that to something like this, where we have an interface that takes requests and sends out responses. But in the meantime, in order to formulate its response, it goes and talks to our application directly. So let's try this out. So for an example application, I picked the part of the tutorial in the Getting Started guide in the Elixir site, and there's a couple of reasons for that. One is it's a tutorial that's already out there. Anybody can go follow the steps, create one, and do exactly what we're doing here. Go try it at home. Two is it's not enormously elaborate. There's not too many moving parts, so we can cover it in the time allowed, and also doesn't use a database. It acts as its own database, so it is a stateful backend. So step one, we generate the new mix application. This is very standard. We just changed the name with the -- module flag to make it all uppercase, and we make it supervised with -- sup. Then we follow the rest of the tutorial. Actually, there's a few pieces that we won't be talking about. I want to focus mostly on the gen server because that is going to be the interface, the public interface to our application. So there's an agent and things that you'll need, but we're not going to cover right here. So we are going to cover the gen server. We're going to build it out for the key value store. This is all the code for the whole thing. We're going to go over it in more detail, but that's it. That's all we need for the gen server. So when we look at this file, so from there up are what are known as client functions. So those are the public interface. Those are the functions that other parts of the code are going to call. And then from here down, those are callbacks that we implement. So we'll take a look here. That's a little bit easier to see. There's an interesting thing, which is that each one of these client functions, which is from the top of the file, they all wrap a function from the GenServer module. And there's a reason for that. So whenever a function from the GenServer module is invoked, it immediately invokes a callback. And there's a direct mapping from function to callback that gets invoked. Okay, and then these are the callbacks. And now let's start building. So we start with just a plain module, and we inject the common GenServer code into it. And immediately, this is going to start working like a GenServer. It's going to behave like a GenServer. And you'll notice this is the capital G, capital S version. That's an Elixir module that wraps the Erlang module, which we would call as the Atom gen_server. And this gives us a lot for free. It gets rid of a lot of the boilerplate. There's a bunch of callbacks that we must implement versions of in order for the thing to work, but GenServer capital G, capital S takes care of it for us. Okay, so really these, the client functions and the callbacks operate in pairs. Right, so this is the first pair that we're going to talk about, startlink. So we need to actually start one of these things as a separate process. So startlink 0 is our client function, and then it wraps startlink 3, the GenServer function. And we need to tell it which module that we're going to start, and that's just the one that we're using. We also need to tell it what we're going to pass to the callback. Here we're just going to pass the Atom OK. And as Sasha told us yesterday, we can give a name to our GenServer so that we don't have to keep track of the PID all the time. We can use this Atom. Now this, as Sasha said, effectively makes this kind of a singleton. Because if you try to, since it's hard-coded here, we can't start two processes with the same name. So it will tell us bad things if we try to start a second one. So now that we're calling startlink, that's going to invoke the init callback, and we're pattern matching on the value. So we could actually have multiple clauses of init if we wanted to. And then we get the return value. So this will not get passed back. Nothing in here will get passed back to the caller. This return value will be used by GenServer internally to figure out what to do. So OK, just said everything's going fine. And the second element of the tuple sets the initial state for the GenServer. So GenServers hold state just the way agents do, and this is the initial version of that state. All right, and then we've got the second pair, lookup. This is just going and you get a name, and you're going to see if that name has already been put into our key value store. Here's the interesting bit. So this server, anytime you have a call to a GenServer module function, you need to give it a server to operate on. And in our case, instead of the PID, we'll just pass in the name that we gave it previously. Okay, and we are using GenServer.call. Call is synchronous, so we will send something back to the caller. The caller is waiting for it. And this is the second argument here is the thing that we're going to pass into the callback. And this can be pattern matched on, so we can have multiple versions of the handling callback. All right, so we had a GenServer.call, so our callback is handle call, makes sense. Pattern matching on that. The GenServer knows the PID of the process that called us, and it passes that in as the second argument here. If we wanted to, we could use it. We're not going to use it, so we prepend it with an underscore to keep the compiler happy. And this is actually the state. So every time you have a callback in a gen server, the third argument is going to be the current state of the gen server at that time. And we're going to use it, but we're not going to change it or transform it at all here. So this reply too is also an intermediate reply. The gen server itself is going to use this in order to figure out what to do. So what's actually going back to the caller is this bit right here, and it's just fetching the name from the state. Then we also return the state. We might have, along the way, altered this, and then that new state would become the current state of the machine. And create, this is our last pair, works basically the same way. This is the thing that we're going to pass into the callback, pattern matching. So this function basically, if it finds something, if it finds the name that gets passed into it, it will return it. Otherwise, it's going to alter the state here by putting that new key and value into our state and return that. So now that we have that built, we can register our key value, that module that we just did as a worker, the registry, with the application, start it up, and now that's built. Now we have our application, and now we need the interface. So we're going to build a new Phoenix application. This is pretty standard. We're just going to call it KV interface, and we're going to not use ecto. And now we need to bring the KV application, our Elixir application, into our interface. We just do that by adding it as a dependency to the KV interface application. And we're using a path type dependency here. It's just easy because then we don't have to publish it anywhere. We could use a GitHub one or a Hex one if we wanted to. And then we add KV to the application list. This is in KV interface. We just add that into our list of applications. And we can check again to see if they're there. And they are. So now we're almost done. We just need to get them to talk to each other. And so here we'll use a controller to do that. We'll just have a regular controller. Then we can add a show action. And this looks basically exactly the same as any other show action, except that we're talking to our Elixir application. So it's a tiny little difference in this one action, but for the whole thing, it's a huge, huge change. And the same thing for a create action. So really, what have we gained here? I think the big thing is isolation. So we've been able to develop the application in isolation. We've been able to test it in isolation. We've gotten our domains separated, and that gives us maintainability and portability. And if we think about our thought experiment earlier on, if this were possible in the Ruby world, that task would not have been nearly so daunting. So, and as Leonard mentioned, yeah, I'm the author of the Phoenix Guides, principal author of the Phoenix Guides. And you know, the Phoenix core team, we've been talking about these things. And part of our job is to educate folks. And in a way, we've perpetuated a lot of the ideas that have come from almost cargo culted from other frameworks. And that's useful, but I think it's now time that we kind of move on and see what the Erlang virtual machine allows us to do and embrace that because it allows us to do so much more and so many more interesting things. And that's a wrap. Thank you. Thank you.
So, do we have any questions?
You say if it's possible to do it removable, so it's possible you can create class, you can set class variables, you can hold your state within this class, and you will get the same stuff. But what if we want to implement a new site in this way? So user hit the page and he should see news. How would this approach help the whole database state in this process?
So I heard maybe a couple questions there. So if I don't answer all of them, please let me know, okay? So why would we want to do this in a new application? I think one, for maintainability. I think one of the things, many of us have Rails as a common heritage. We see is that as an application matures and grows, it's very difficult to manage. They become very difficult to manage. If we begin in this way, we can add multiple Elixir applications to handle multiple scenarios, right? Or multiple new things that we need to do within an application, right? And they're isolated, they're separated from one another. And I think you were asking something about like how do we handle state if it's not in the database, like if there's a problem, the server crashes, something like that. I mean, I don't know if I understood the second half of your question.
I mean, for example, if you have a news site, you have lots of news. So you can just put all those news in and hold the state of, actually you will mirror the database in the process and it's not feasible. That's what I mean.
Maybe. It just depends. I remember Joe Armstrong saying, I think it was on a podcast, maybe the Mostly Erlang podcast. He was asking, how would you build Twitter today if you were using Erlang? He was saying you would have a process for every user. You would have a process for all of their feeds. And you would save all that in memory statefully on the server. Chris has got a...
I'll just say that all you would need to do to support multiple applications was Lance's key value app would just take a couple, let's say, of the application name or the OTP app that wants to store key values. So then you still have one key value app and new key values, which is namespace things. That way, every app is right there. You don't have to worry about kind of behind flashing. You just look at all of the instruments with one extra element.
Just a quick question, really. So you made your app a dependency on Phoenix, is that right?
No, the other way around.
Yeah. Okay. I was going to ask you.
Yeah.
That way around. So Phoenix is a dependency.
Yes.
For your application. Yeah.
Well, no. So you bring KV into the interface. So you bring the Elixir application into the Phoenix interface.
Okay. Yeah. So can you do it the other way around, or you wouldn't want to do it?
I don't know that you would want to do that.
So you have to dodge that question. Anyone else?
So I think what you're talking now is also like connects with my idea that Ecto is also a model that you should use Ecto to build your model layer that is much richer than just having simple like data that you fetch from the database and that's all. So yeah, it's more like a remarkable question that it fits really nicely into this idea.
Great. That sounds fabulous.
So if there's not a model, then Phoenix is not your application. Do we have another one? I didn't see any hands. Well, in that case, thank you very much.
Thank you. Thank you.